Welcome back to the video portion of Unit 12. We're going to start talking about business statistics. According to your author, frankly, in a broader sense, I sometimes prefer the title of descriptive statistics. Think of it this way. You've got a chunk of numbers, a chunk of data, and you have to find a meaningful way to describe them so that somebody who isn't fascinated by having tons of data to sift through can gather some informational meaning about what the numbers suggest. So that's what we're going to attempt to explore in Unit 12, content found in your textbook in Chapter 5. All right, it's time to begin our first video. So there's your preface slide, pretty spiffy, I dare say. What's going to happen in Unit 12? We'll talk about getting Excel involved as we generate some things to help us process the visual and analytic part of data analysis. Some sketches, some graphs. Some of them are easy to make, some less easy to make. We'll talk about mean, mode, and median in section 2. We'll wrap it up by talking about dispersion. How much does the data spread out? The ones that you're probably familiar, at least with the phrases there, are range, which is easy to find, maybe standard deviation, which is not as easy to find, and that'll put a pretty bow on what we do in unit number 12. All right, so as you heard me say previously, while your author talks about business statistics as it relates to these ideas, I think in a broader sense, it's probably better to call them descriptive statistics. How do we describe the data? What do we know about the data? How can we make that data be meaningful to somebody who doesn't have the tolerance to actually maybe look at every number that came in as part of that data stack? So we talk about ways to summarize. We talk about ways to present the data pictorially in a fashion that somebody can look at and say, oh, wow, I see that, without having to stare at every number that came in. So objectives for us as we ponder Unit 12, you're going to notice that we'll look at some pictorial presentations in Unit 1. In Unit 2, or I should say in Section 2, we'll talk about means and modes and medians. Again, things that probably you have done in the past. I don't think that's going to be a challenge. I don't think anybody gets too intimidated by those notions. We'll wrap it up with how do we measure dispersion? How clustered is the data? How spread out is the data? And we'll wrap down the unit with a little bit on normal distribution. The normal curve is the bell curve. And some of you have done some work with that possibly in classes in high school. And we'll take a look at something that basically gives us a handle to look at how much data we can expect to fall within one standard deviation of the mean. And those are a lot of mathy words that'll have some more meaning as we get closer to the end of Unit 12. All right. So here's your basic setup. You're sitting there at your desk, you got your cup of coffee, you got your Hostess Twinkie, you're ready to start the day, and the boss comes in and dumps a 1,005 data point stack of numbers on your desk and says, make this meaningful. Make this something that people will look at and be able to draw some inference based on what the data says. And you've just been tasked with the process of descriptive statistics. You may have to take that and find something analytic, something numeric about it. You may need to present that in some graphic method that somebody can look at and say, oh, yeah, I see where the biggest bar is. Most of them seem to be in there. So that's what we're going to look at in this unit. And as I said, some of the things I'm certain that you've done before. Here's a lovely little visual. So you're going to be a big old data stack, and you're going to do some descriptive statistics work, and we're going to print out or punt out some information that is meaningful, that someone will be able to look at easily and draw some inferences based on what we've presented that they wouldn't be able to or willing to do if they just had to look at all that stack of numeric data. So that's the job of descriptive statistics. Put it out, analyze it, and put it out in some kind of a context form that's easy to discern. Okay, section 5.1, frequency distributions and graphs, meaningful ways to represent our data. So on the screen now, you've got Chester CPU, and he's a consultant for Dell with 2 L's. And he's surveyed, looks like 20 freshmen here at IU, and he's determined how much they've spent for their computer rigs. And he's going to do something that talks about how much money IU freshmen spend for their computers. So, okay, you could certainly present the 20 numbers. 20 you might be willing to have people look at, but if we're 20,000, they're all going to go play golf and say, you figure this out and give me something of meaning where I don't get so bogged down by looking at that much data. So, all right, what we're going to do is we're going to build our first frequency distribution using our numeric data. So what Chester could do is he says, hey, you know what? It looks like everything's an even thousand. So I'll tabulate how many were 1,000, how many were 2,000, and so on. And you could create something like that with your little tally marks and figure out how many were in each particular price point. And that is your first example of a frequency distribution. Sadly, not many frequency distributions are a single number on each class. Most tend to be a range of numbers on each class. So Chester may decide that, okay, well, that's nice, but I wouldn't do it that way if instead of only 10 prices, there were maybe 70 different prices. I wouldn't want to do it in that context. I might choose to change those class levels, and that's what you're going to see next. Okay. He says, well, dang, maybe I'll consolidate some of those classes and I'll look at price points from 1,000 to just a smidge over 3,000, from about 3,001 up to just a smidge over 5,000. Same data information as before, but we've shrunk down the number of classes. So instead of having 10, where each class was only a specific price point, we're now looking at 5 separate classes where each class is a range of values from this to this. All right. So if we take Chester's data, again, we find some meaningful information that looks like a large preponderance of the 20 people. In fact, over half of them spent less than $3,000 or less than $3,001, I should more accurately say, on their computer. Okay, so there's our set for our frequency stack using a different class structure. We'll take that information and we can build bar graphs where the height of each bar talks to us about how many times that particular price point showed up. So for our first class interval set, where every interval was just a single price point, our bar graph would look like this. The fact that the tallest stacks are at 1,000 and 3,000 seems to fit with what we had, where there were 5 people whose computers cost 1,000, and there were also 5 people whose computers cost 3,000. So the important thing is now we've introduced the visual aspect. A great number of people who aren't fans of mathematics will look at input data by vision. They'll say, oh, wow, I see where the tall stacks are. They must be the important ones. So you can get your eyeballs to wrap around some information where maybe those people would look at the stack of numeric data. All right. If we do the same kind of an idea and build some kind of a bar graph for our second frequency distribution, again, it shows without doubt that a great number of our people are in that first class from 1,000 to just under $3,001. And again, you can count how many by looking at how tall the stacks of the bars are. If you and I are going to build a frequency distribution from scratch, it has to be able to span all of our data points. So some authors advertise or advocate a fixed width of the class. So your class intervals should be 10 wide. Others say go find the largest, go find the smallest, and then divide by the number of classes that you want your frequency distribution to contain. Your author is an advocate that we don't want too few, and we don't too many either. So he advocates somewhere between 5 and 20. And again, I think, whether you're going to tend toward 20, you're going to want a bigger span in the numbers, I think. You're going to want something that measures maybe hundreds to something that measures, multiple thousands. And then I think maybe you could justify having 20 classes. I think most of the frequency distributions that I've created, that I've worked along the way, probably tend to, maybe 5 to 10. Okay. Second visual for us is the notion of a line graph, and they basically are built to look at trends over time. And the time may be years, maybe months, maybe days. And again, it's a visual look. So if you're following the red line across the top, you indicate a tendency. And it looks like that one's dropping. It kind of leveled off for a while there in the middle, and then it seems to be dropping again. So it's a visual attack. A great number of people will look at it, draw some inferences from the look of the picture that they wouldn't be willing to do if you simply gave them the numbers that corresponded to the price points for each of those years. All right. And a lot of times when you are looking at line graphs, you'll compare more than one thing. So it's not out of character to have multiple lines on the same line graph. Another visual force, you've probably heard them called pie charts. Your author refers to them as circle graphs, where you look at all of the content and break it into categories, and each category is a wedge of a circle. For those of you who played Trivial Pursuit back in the day, I know I'm dating myself here, but those little wedges that used to play for are what we're creating here. In Trivial Pursuit, they were all the same size. But in a pie graph where you've got different percentages constituting different sets of your data, it's quite often that the wedges will be of different size. So if you're going to create one old school, you need to recognize that all the way around is 360 degrees. So you would take your percentage. Suppose I had something that was 40% of my data stack, and I would multiply 40% by 360, and that would tell me how many degrees worth that should be in my circle. The good news is Excel does this pretty swell, and we'll have a couple examples here. I like this. I stole it from an internet site, and you can tell it's stolen because the spelling of the word favorite, you know. But I like the colors. I think it presents well. What I find I would have wished for is, in addition to the colors and the scaling out there, and the so I know that the blue is football and the pink is basketball. I kind of wish the percentages had been included as well. So I took this information and I modified it, if you will, and I created my very own circle graph where probably could have made the a little bit bigger for us to see. But you see, I included the percentages because I think it's more meaningful. Still got the scale there for us to consider. We've got football at blue and basketball now. All the Celtic fans happy to be in part of that orange cluster at 25%. Index numbers are ways for us to track changes. You've heard of the consumer price index. That's probably the one that's most practical for us. It's relative to 100. So as we see changes relative to 100, we simply report the changes. So when the CPI is 105, it went up 5%. All right, so if you're going to do price relatives, and this is an honest to God example, I bought my first calculator when I was a senior in high school, and I probably spent about $80 for it. And God bless us, it's about as big as a shoebox, and it adds, subtracts, multiplies, and divides, and has memory. And it was more than $75. The same calculating power now can be bought for say $5. So if you were to say, well, what are the prices relative to one to the other? We're going to build a ratio. That's all this is. It's the current price relative to the base year. And the current price for that calculator is $5 compared to what used to be 75. So you know what? That processing power, that calculating power now basically costs about 6% of what it would have cost way back in 1972. So it's a price relative, comparing price points. Understand that you're putting the current price on top relative to what it used to be on the bottom. So this time we got 6.6 roughly, 6 2/3 if you want to be hyperactive as it relates to this particular problem. Here's your CPI chart. I actually pulled this thing off their website, trying to track what we've got for the Philadelphia area. And I like the fact that they put the little bars across for you in bright red, considering everything. And then if you take away food and energy, you've got the broken or the dashed blue line. And it seems like that seems to be more of a factor in terms of rising. You got gas prices and whatnot. So again, it's a nice visual for somebody to look at. You say, all right, well, for a while there, things were looking pretty rocky. Now those prices seem to be trending down as we look into the beginnings of 23. It will be interesting for you and I as we approach what's happening in 24 and into 25, certainly. And that, my friends, is the end of video 1 from Unit 12. I'll be back soon with video 2. See you then.